The work is complete.
Good.
It cannot move.
Machine problem.
No. It is pending approval.
For how long?
The record says pending.
So we know everything except the time.
Right. And I mean, that exact scenario is exactly what we're jumping straight into today for this deep dive.
It happens every single day.
It really does. So for everyone listening, today's mission is unpacking a phenomenon from a fascinating operational document we have. It's called Field Note Number 012, the approval queue nobody measures.
It is a phenomenal look at a very specific problem.
Yeah, it is. And we are going to explore why finished, physically completed work so often just sits in this state of administrative paralysis. You know, why these invisible approval queues escape all of our normal loss reporting systems.
Right, because you never see them on the standard reports.
Exactly. And most importantly, we want to look at whether you are a supervisor, an operator, an engineer, what you can actually do about it on your very next shift to start fixing this.
And setting the parameters for this discussion right up front is crucial here. We are taking a really rigorous, professionally serious, systems-level approach to this.
Right. We aren't just ranting about bureaucracy today.
No, not at all. We are looking at how operations manage that specific, highly vulnerable gap between physical work being finished and the official permission to continue. We will look at how to implement measurement, specifically through request and completion timestamps.
Which sounds simple, but is actually huge.
It is, and we will get into how to build escalation structures that don't just rely on sheer luck or someone getting annoyed. The entire goal is to illuminate recurring causes of delay, and we're doing this entirely without personalizing system failures or blaming individuals.
Which is so vital, honestly, because my first instinct as a practitioner is to look at a stagnant queue and just wonder, who is slacking off in the quality department today?
Which is the natural human reaction, but it's almost always the wrong conclusion.
Right. But before we get to that human element, let's define the physical reality of this queue. Because when you say approval queue, people usually visualize, a chaotic backlog, right?
They do, yeah. They picture smoke and fire.
Exactly. They picture a staging area overflowing with broken parts, or a massive traffic jam of forklifts blocking a loading dock, or just a digital dashboard flashing with hundreds of overdue red alerts.
But the sources suggest this specific type of queue looks entirely different in reality.
It really does. It looks dangerously serene.
That's a great way to put it. Consider an illustrative sequence rather than a reported case from a specific plant. Picture a highly valuable precision-milled aerospace component.
Oh, I can picture that.
It rests inside a completely clean, well-lit inspection release area. It is flawless. It is completely ready to move to the next operational cell.
So the physical work is entirely done?
Entirely done. Its route is blocked by nothing more than an immaculate approval document that is just missing one supervisor's physical signature. Or perhaps it's waiting on one engineering clarification regarding some microscopic deviation.
Wow. So nothing actually looks broken?
Nothing at all. The orderliness of the environment actively masks the problem. I mean, the queue is perfectly organized, yet it is entirely stationary.
Okay, let's unpack this. Because the work is waiting for something legitimate, right? The sources actually list a few specific categories that routinely paralyze production like this.
Right, these aren't frivolous delays.
No, we are talking about a formal inspection release from a quality control lab, or a supervisor's signature on a physical routing card.
Or sometimes it is an engineering clarification, as we just mentioned.
Yeah, or it could be a deviation decision, like where someone with explicit authority has to formally decide if a part that is, 1 micron out of spec can still safely proceed.
And another incredibly common variation of this is the system permission bottleneck.
Oh, right, the digital lock.
Exactly. This is where the physical work is completely done, but the entire operation just halts because one specific digital lock remains closed in the software.
Right, because it requires access from the one individual authorized to log into the system and actually click the necessary release button.
And because these delays lack the dramatic visual cues of a machine breakdown, I mean, there is no smoke, there's no loud grinding noise, no flashing red alarms, they become this accepted, almost invisible part of the background noise of daily production.
It's just part of the furniture at that point.
Exactly.
Well, let's put some strict definitions on this process, because the source material demands precision here. And frankly, if I'm running a shift, I need to know exactly what state the work is actually in.
Defining the states is the only way to measure them.
Right. So the first state we need to define is work complete.
Right. And work complete means the required physical or digital operation has been performed in its entirety. The milling machine has finished its cycle. The assembly is bolted together.
Or the code is compiled if it's digital.
Exactly. The
Yeah.
primary task itself is over, and the operator has stepped back from the work.
Okay, then we move to the next definition, which is where things usually start to get a bit muddy in reality, and that is approval requested.
And the definition here is foundational to literally everything else we will discuss today. Approval requested means the accountable approver has received a sufficiently complete request, according to the local definition of what complete actually means.
That caveat is carrying a lot of weight there.
Yeah.
Sufficiently complete.
It has to carry that weight. It really does.
Yeah.
I mean, it does not count as an approval requested if an operator just, yells across a noisy shop floor that they need a signature.
Right, or if they just drop a half-filled form on a desk without the required metallurgical testing logs attached or something.
Precisely. The request must be submitted according to the agreed-upon local standard with all the necessary data, so the approver actually has the raw material they need to make a real decision.
That makes sense.
Yeah.
Which leads directly to the third state, approval completed. And I imagine this is not just a supervisor making a mental note that the part looks fine.
No, definitely not. Approval completed means the authorized decision has been actively recorded and communicated according to the formal process.
So the signature is literally on the paper.
Or the digital button has been clicked. The official system of record reflects that the decision happened.
Right. And finally, the fourth state, work released, which simply means the approved work is now officially permitted to continue down the line.
And those four definitions.
Right.
Work complete, approval requested, approval completed, work released. Those act as the strict boundaries for our measurement.
Right. But I need to push back here for a second, or at least play the role of a production manager who is already drowning in paperwork.
Fair enough.
Because if I look at the sequence, I just see a normal Tuesday. I mean, isn't waiting for a signature just an unavoidable administrative pause?
A lot of people feel that way.
Right. It's just the cost of doing business in a regulated environment. Why should a management team treat a missing signature with the exact same engineering intensity and root cause analysis that they would apply to a catastrophic machine breakdown?
Well, treating that approval as a mere administrative pause is actually the cultural architecture that allows the queue to exist in the first place.
Wow. Okay. How so?
Think about it. When a physical machine goes down for 45 minutes, the entire floor reacts, right?
Oh, yeah. Maintenance is dispatched immediately.
Exactly.
Yeah.
Downtime is logged on a loss report, and weekly operational meetings discuss the root cause so it doesn't happen again. But when a completed component sits on a table for 45 minutes waiting for a supervisor to sign a release,
It barely triggers a response at all.
it rarely triggers any response.
Oh.
But operationally speaking, the consequence to the factory's output is identical. The flow of value has stopped.
Ah, I see. The machine is effectively down, even if its spindle is still spinning on the next part, because the overall system throughput is blocked at that table.
Precisely. Unmeasured administrative queues consume finite capacity. They delay subsequent operations. They hold inventory hostage. And they do all of this without generating a single visible alarm on the floor.
So it's a silent killer of capacity.
It really is. When leadership categorizes this waiting as just an administrative pause, they were giving themselves permission to ignore the reality that the factory is not actually producing output during that time. The approval process must be conceptualized and managed as measurable production work.
That shifts the whole perspective. But if the impact is really that severe, why do these queues completely escape normal loss reporting? I mean, a modern facility tracks overall equipment effectiveness, or OEE, down to the fraction of a percent.
Oh, absolutely. They track every second.
Yet the sources indicate you will almost never see waiting for a signature categorized as a major loss category on a standard shift report. Why is it invisible?
What's fascinating here is that the invisibility stems from the highly distributed nature of the delay. The waiting doesn't belong to a single person or a single piece of equipment. It crosses departmental boundaries. It spans different software systems, different email inboxes, and often different operating shifts entirely. Different systems record different disconnected parts of the process.
So everyone can technically be working.
Yes, everyone is working.
And the physical work can still remain totally stationary.
Also, yes, it is a remarkably collaborative form of waiting.
That is wild.
Production is busy setting up the next job. Quality is busy reviewing a backlog of earlier parts. Engineering is busy drafting a clarification. Everyone is highly active, but the specific component we actually care about is immobilized.
It functions very much like a massive group text trying to coordinate dinner plans, doesn't it?
That is a perfect analogy, actually.
Right, because one person is researching restaurants, another is checking their budget, a third is looking up train schedules. Everyone is technically busy participating in the coordination. Everyone's phone shows those little typing bubbles.
But nobody has booked a table.
Exactly. The actual dinner plans remain entirely stalled. Activity is constantly mistaken for progress, and because the friction is shared among 5 people, no single person feels the acute pressure of being the sole bottleneck.
And the asymmetry in how we view precision in these two realms is striking. I mean, manufacturing environments will measure the cycle time of a physical cutting operation down to the exact second.
Oh, absolutely. They calculate the exact feed and speed required to shave mere milliseconds off a cycle.
Right. But when that exact same component enters the administrative phase of its journey, the measurement suddenly degrades to a highly flexible unit known as shortly.
Huh. Yes. We will get to it shortly. Or the engineer will be down shortly.
Suddenly, precision just has departmental boundaries. The physical engineering side is managed with rigorous data, and the administrative side is managed with, well, vibes.
Just general feelings of when things will happen.
Exactly. Which brings us back to the danger of the word from our opening scenario. Pending. Pending is a status. It is not a unit of time.
Let's dwell on that distinction for a second because it feels central to the whole problem. When an operator looks at a screen and sees a part listed as pending, what critical operational information is that word actually hiding from them?
It obscures the timeline entirely. It hides when the request actually began. It hides exactly how long the component has been sitting there. It hides whether the request was even complete when it was submitted in the first place.
It's just a black box.
A total black box. And most dangerously, the status of pending separates the responsibility for the decision from the operational consequence of the delay.
Right, because the person sitting in an office 3 buildings away looking at a digital queue of requests just sees a neat list of pending tasks on a screen.
Exactly. They do not feel the physical pain of an operator standing idle on the floor or a shipment schedule falling dangerously behind.
So the label sanitizes the reality of the delay. It makes unmanaged waiting look like organized inventory.
It does. It makes it look like everything is under control when it's actually stalled.
Now, here's where it gets really interesting, but I want to introduce a major caveat here first, because I can hear quality control managers tensing up as we speak.
Right. We need to be very clear about this part.
We are discussing the friction and cost of approvals, but we must draw a thick, uncrossable line between the approval itself and the time spent waiting for it.
That distinction is absolutely paramount. Measuring the wait does not mean that approvals should be rushed, bypassed, weakened, or eliminated. Approvals exist to protect fundamental pillars of the operation.
Right. They protect physical safety on the floor.
Yes.
They ensure product quality and technical integrity. They provide traceability for auditors. They enforce operational authority, and they serve as vital risk control checkpoints. I mean, if we are building medical devices or aircraft landing gear, nobody wants an inspector rushing through a checklist just to satisfy a new time metric.
Measurement is not about the compression of necessary work. The central philosophy we are operating under is this. The approval may be necessary. The obscurity of its queue is not.
I love that. Just because a signature ensures safety does not automatically mean that a 3-hour wait for that signature is also ensuring safety.
Exactly. Unmeasured approval queues do not magically inherit the noble justification of the approval itself. The wait is simply waste.
It's just lost time.
Pure lost time. The objective of shining a light on this queue is not to force people to read documents faster. The objective is to determine exactly when the need for the approval became known.
Right. When was a complete request actually submitted to the accountable person?
When was the decision finally completed?
Yeah.
What structural factors prevented a timely response? And perhaps the most diagnostic question of all, could this approval process have been initiated earlier in the operational cycle?
Ah, okay. Like, could we have started routing the paperwork or gathering the testing data while the machine was still cutting the metal instead of waiting until the spindle entirely stopped?
That is the architectural question you have to ask. Why does the administrative decision process frequently only begin after the physical work has already started waiting?
It's sequential when it could be parallel.
Exactly. By studying the queue, we aim to design a system that delivers the request to the approver at a better time and in a better format, so the idle weight never materializes in the first place.
So the source material actually provides a deeply relatable timeline to illustrate how this plays out in reality. I will outline the 8 steps, and again, for everyone listening, consider an illustrative sequence rather than a reported case from a specific facility.
Right, this is a composite example.
Right. So, step 1, the work is completed. The operator finishes the physical task.
Step 2, inspection or release is required. The routing documentation clearly mandates an authorized signature before the component can advance.
Okay. Step 3, a request is made. So the operator places the paperwork in a designated tray or perhaps selects a name from a drop-down menu in a software system.
And here is where the architecture normally fails. Step 4, no request timestamp is recorded. Right, the system notes that a request exists, it updates the status to pending, but it completely fails to record the exact moment that request was initiated.
Which leads inevitably to step 5. Informal follow-up begins. The wait stretches on, and the operator realizes their shift metrics are going to suffer if this part doesn't move.
And the informal follow-up is such a fascinating human adaptation to a system failure. When you walk a factory floor and ask teams how they know an approval has waited too long, they rarely point to a digital alert.
Right, they don't have an alarm.
They rely on social capital. The answer is almost always, well, eventually a supervisor walks over to the lab to see what is taking so long. That informal tap on the shoulder is functioning as the primary escalation protocol for a multi-million-dollar production line.
That is terrifying. The escalation structure is literally just a guy named Steve walking across the building when he gets sufficiently frustrated.
And Steve only begins that walk when the operational pain of waiting finally exceeds his natural human reluctance to go bother a colleague.
Right, nobody wants to be the nag.
Exactly. Which means a massive amount of production time has already been lost before the first intervention even occurs.
Wow. Okay, continuing our sequence. Step 6, additional information is requested. So Steve taps the inspector on the shoulder. The quality inspector finally looks at the paperwork and realizes the operator forgot to include the temperature logs from the furnace. The request is bounced back.
Step 7. The approval is eventually completed. The operator hunts down the temperature logs, the inspector reviews them, and the signature is finally applied.
And finally, step 8. The final record is generated.
And the tragedy of the final record is what it completely conceals. The paperwork looks immaculate. It reveals the final decision approved, but it entirely hides the chaotic interval that preceded it.
It just shows a success story.
It hides the initial the informal tap on the shoulder, the missing temperature logs, the rework of the request itself. All of it is gone.
So the history shows that approval happened.
Yeah.
But not that production developed a meaningful relationship with the word shortly.
Exactly. The system is perfectly designed to record the ultimate outcome, but it is entirely blind to the friction required to achieve that outcome. When a plant manager or an auditor reviews that routing card 3 weeks later, they see a successful, compliant process. They do not see the invisible capacity loss.
That makes total sense. Now, the instinct, especially for any management team reading a field note about unmeasured processes, is to buy a solution, right?
Oh, always.
The immediate reaction is to call an enterprise software vendor, purchase a massive new predictive workflow management suite, and issue smart tablets to every single operator on the floor.
But introducing a heavy digital platform to solve an unmeasured, poorly understood problem usually just digitizes the existing dysfunction.
It just makes the bad process happen on a screen.
It allows the bad process to execute faster, and often with significantly more annoying notifications. The intervention recommended in the source material is starkly different from that. It is a practically useful, remarkably low-cost method.
The solution is simply adding 2 timestamps to the existing record.
2 timestamps. That is the entire foundation of the measurement.
Just approval requested and approval completed.
That's it.
If the facility uses physical paper travelers in plastic sleeves, you literally just add 2 blank lines to the printed form. If they use a basic legacy database, you add 2 data fields to the screen.
And the power of that empty field cannot be overstated. Picture that physical routing document traveling with the work. The approval completed line remains blank.
Just staring at you.
Right. And while that line is blank, physical work carriers, loaded with heavy, incredibly valuable components, quietly accumulate behind it in a precise, restrained line. That empty field is silently dictating the entire pace of the factory.
It changes the visual language of the problem. A blank space actively asking for a time is much harder to ignore than a generic pending status on a screen.
It demands an answer.
I look at this intervention like a mechanical dashboard. Imagine driving a car where the check engine light is wired to a panel hidden under the hood, rather than on the dashboard in front of the driver. Adding these timestamps isn't rebuilding the engine, right?
No, not at all.
You aren't changing the flow of the fuel, you are just taking the indicator light and weshering it to the dashboard where the responsible party can actually see it illuminate.
It's brilliant in its simplicity. A highly observable, measurable interval replaces a vague description. And once that interval is visible, the team can begin to gather necessary context around it. Because the timestamps alone are the foundation,
Yeah.
but the record should also capture a few critical qualitative data points to make the measurement truly actionable.
Right. What else needs to be on that form or in that digital field besides just the 2 times?
First, categorize the approval type. The system needs to know if it is measuring an inspection release, a supervisor's authorization, an engineering clarification, a system permission, or a deviation decision.
Because throwing all of those into one giant bucket called administrative delays doesn't help anyone solve the actual problem.
Not at all.
Waiting for an engineer to run a structural simulation on a deviation is fundamentally different work than a supervisor just glancing at a batch number to sign off on a shift change.
Exactly. Different work requires different baselines. Second, the record should track the reason for any extended delay, particularly if the request arrived incomplete. Was there missing information? Did the operator forget the logs?
That shifts the focus back to the quality of the request itself, rather than just blaming the approver for being slow. I mean, if the request was garbage, the approver couldn't do their job anyway.
Exactly the point. Finally, the record needs to capture whether escalation was required. Did the system work as designed, or did someone have to manually intervene to force a resolution?
Which brings us to the operational architecture required to actually support these timestamps. We talked about Steve walking across the floor to tap someone on the shoulder.
The infamous Steve protocol.
Right. Steve's frustration level is currently the entire escalation protocol. How do we build a structure that does not rely on a human being just noticing that a request has grown stale?
Well, this raises an important question about system design. An effective escalation rule must be based strictly on waiting time, completely divorced from human observation or individual frustration. The system itself must flag the passage of time.
Okay, so how do we do that?
The sources propose a straightforward 3-tier escalation structure as a model for how this can work.
Walk us through the mechanics of those 3 tiers. What's the first one?
The first threshold is designed to notify the responsible role. Once the locally agreed upon time limit has expired, a formal notification is triggered to the primary person accountable for the decision.
So it replaces the tap on the shoulder.
Yes, it is a prompt, not a punishment. It signifies that the wait has just exceeded the normal operational boundary.
It removes the need for Steve to walk over entirely. The system taps the primary approver on the shoulder. But what happens if they are in a meeting or off-site and the wait continues?
That triggers the second threshold. Escalate to the designated backup. The system recognizes that the primary approver is either unavailable or unable to process the request. It automatically moves the authority to a predetermined secondary individual.
Which is smart.
It is a critical structural safeguard against the single point of failure bottleneck.
And if the backup is also unavailable or the delay pushes even further, what then?
We reach the third threshold. Involve the accountable operational owner. At this stage, the unmanaged wait has become a systemic issue that is actively degrading production capacity. The plant manager or the shift director is notified not to make the technical approval themselves, but to clear the administrative or resource blockage that is causing the paralysis.
I mean, this structure sounds incredibly logical on paper, but as a practitioner, I can tell you that the moment you try to implement time-based escalation on a factory floor, it triggers a massive political turf war.
Oh, invariably.
Right. Who sets these time thresholds? Does corporate headquarters just declare that all approvals globally must happen within 15 minutes?
Mandating universal time thresholds from a corporate office is a guaranteed path to failure. It never works.
Why not?
Because the scale and pattern of waiting must be measured locally. The actual thresholds must reflect the reality of local processes, local technical risk, and the actual response structures available on that specific site.
Because 15 minutes might be entirely reasonable for a shift supervisor to approve a routine tool change, right? but it is dangerously insufficient for a metallurgist analyzing a complex structural anomaly.
Yeah, exactly. If the approval realistically requires a 2-hour technical review, setting the first escalation threshold at 30 minutes only generates alarm fatigue and animosity.
They'll just start ignoring the alarms.
Completely. The rule should support and protect legitimate decision-making, not encourage hurried, unsafe approvals just to beat an arbitrary timer. The teams doing the work production, quality, and engineering must negotiate and agree upon these thresholds locally.
But how do they agree on a baseline if they have never measured the queue before? I mean, if production says they need the approval in 10 minutes and quality says they need an hour, you just have two departments shouting at each other based on gut feelings.
This is where the diagnostic methodology comes into play. You do not argue about hypothetical baselines. You conduct a 1-week observation. You gather the raw reality of the floor.
What does that 1-week study actually look like in practice? How disruptive is it to the shift?
It's not about disruption. It is an exercise in meticulous, temporary observation. For one single week, the operational team commits to recording the data we have outlined on every single approval request. They log the approval type, the exact request time, the completion time, and the total waiting duration.
They're essentially running the timestamps manually to see what the invisible queue actually looks like?
They are building a map of the unmanaged waiting. And crucially, during this week, they meticulously record if there was missing information in the request, if rework was required before the approval could proceed, and they track any repeated causes of delay or unavailable roles.
I can imagine the amount of anxiety this generates on the floor, though. If I am an inspector and suddenly production is logging exactly what minute I received a form and exactly what minute I signed it, I am going to feel like I am under a microscope.
That is a very real concern.
I'm going to assume management is building a case to discipline me for being slow.
And navigating that anxiety is the primary leadership challenge of this entire endeavor. Implementing measurement can easily degrade into a punitive surveillance exercise if the culture is not deliberately managed. The data gathered during the 1-week observation is not for blaming individuals. It is not designed to measure the velocity of a specific person's signature.
Because the moment a manager walks into a review meeting and asks, "Why did John take 2 hours to sign this batch record?" the system is dead.
Completely dead.
John will simply find a way to game the timestamp, or he will just refuse to accept the request until he is already finished with the work.
Right. The review is meant to improve the system that is creating the queue, not to punish the people trapped inside it. Leadership must actively refuse to personalize system failures. Instead of asking who took too long, the review must ask structural questions.
Okay, so what kind of structural questions should they be asking when they look at this week of data?
They look for recurring patterns. Which specific approval type waits most frequently? Which category of decision produces the longest consequential delay to production? How often does a request arrive incomplete, requiring the approver to hunt down missing information?
That last point is huge. If the data shows that 40% of delays are caused because operators are submitting routing cards without the necessary testing attachments, then the quality inspector isn't the bottleneck at all.
Not even a little bit.
The bottleneck is a poorly designed, error-prone request process on the production side.
It shifts the entire conversation from personal blame to process architecture. The team should also look at the data to ask, which decisions currently depend on one single unavailable role?
Right.
If the 1-week study reveals that production halts every single day at noon because the only supervisor authorized to approve a specific release is at lunch, that is a system design failure, not a personnel issue.
And how do you fix a system design failure like that? Do you just force the supervisor to eat at their desk?
No, you examine the authority architecture. You ask, which recurring decisions could utilize predefined authority? If a supervisor is manually signing off on a specific, minor, highly predictable variance 100% of the time, week in and week out, the signature is providing no actual risk control.
It is just administrative theater at that point.
Exactly. Can the parameters be predefined so the operator can proceed automatically if the metrics fall within a safe, established window?
So, what does this all mean? It circles back to the most provocative question we discussed earlier. Why does the decision process begin only after the physical work has already started waiting?
That is the ultimate diagnostic question. The timestamp measures the existence of the queue, but the human review of the data improves the system that creates it. If a manufacturing environment possesses the operational maturity to measure physical cutting time to the precise second, it absolutely possesses the maturity to know how long Just awaiting one signature actually lasts.
Right. You bring the exact same level of engineering respect, rigor, and curiosity to the administrative workflow that you bring to the physical production line.
You preserve the necessary control, but you actively identify and eliminate the unmanaged waiting.
Let's summarize the core mechanics of what we have unpacked today. The word pending is a status. It is not a measurement.
Right.
It functions as an invisibility cloak for operational friction and lost capacity. By simply adding an approval requested and approval completed timestamp, you replace a vague status with a measurable interval. You illuminate the empty field.
You make the invisible visible.
You measure the request, you measure the release, and you build an escalation structure based strictly on the wait, rather than relying on Steve's willingness to tap a colleague on the shoulder.
Poor Steve.
Right. And most importantly, you review the resulting data to repair the system, not to blame the individual.
It is a profound shift in how an organization views its own internal friction.
It really is. As we wrap up this deep dive, I want to challenge you, the listener, to take this concept out of the manufacturing plant and project it onto your own operational reality. We have focused heavily today on highly controlled engineering environments suffering from invisible pending queues. But look at your own daily workflow.
It applies everywhere.
It does. Look at your own inbox, your own project management dashboards, or your own team's communication channels. What are the finished, fully completed tasks in your own world that are currently paralyzed? What massive projects are sitting in a perfectly organized, highly collaborative, yet completely stationary queue, bleeding momentum while they wait on a purely administrative yes?
It's a great question to ask.
Watch those empty fields, because the waiting is where the capacity is truly lost. Thanks for joining us on this deep dive.